Hey mathematicians, it's Miss B here. I am wearing my Sequoia Strong t-shirt today because I think it's super important. So you may have seen me wear it before, but in this time I really think it's important that we lean on each other as Sequoiates and remain strong. So I'm going to wear it again. We are going to talk about lesson 1 notes here. This is the first thing we're doing in unit 4, and we're going to talk about key features of equations, graphs, and that kind of stuff. And you did do a lot of this stuff actually in Math 1 and Math 2, so some of this stuff should look very, very familiar. So let's look at x-intercept. So we know that that is where the graph is going to cross the x-axis. Those are our x-intercepts. And our y-intercepts are very similar. So these two things you've actually been learning for a long time since Math 1, and like I said, you did this in Math 2, and you're doing it again in Math 3. So hopefully these two key features of your graphs or your equations are pretty solid in your mind. Now last year in Math 2, you may have talked a little bit about a maximum and a minimum in terms of our parabolas or our U-shaped figures. But this time we're going to expand it out a little bit more, and this would be the highest point on the graph. And sometimes when you see the word maximum, you might see global maximum or absolute maximum describe this, or just plain maximum, depending on the teacher and the textbook and the class that you're taking. But this is really the highest point on your graph. And minimum, of course, is the lowest point on the graph. And again, you might see this be called the absolute minimum or the global minimum. Now, here are two terms that you probably haven't seen before: relative maximum and relative minimum. Another time you might see this as the local maximum or the local minimum. So the relative maximum is a maximum in the fact that I'm going to call it a mountain. So it makes a shape like this where it comes up and goes down, but then it might come up and go down again and go down like this again. So this would be my absolute, this would be my relative. So it's a mountain, but not the highest point. And the same thing for relative minimum. So you might have a minimum, but then you might have a minimum here or here. This is your relative minimum. It is what I call a valley, but not the lowest. So you've got these maximums and minimums, and you might have more than one in each type of graph. And so you may have an absolute highest point, but then you might have kind of a mountain again in the graph. And we will see some examples of that. Okay, increasing and decreasing intervals. And I'm not sure if this is the like textbook definition, but this is what I'm going to say what this is, or what I think it is. I think of slope, and it may not be exact slope, but slope is positive, meaning we are going up to the right. So the graph is going up to the right, and our decreasing interval is where our slope is negative. So down to the right. So like when you learned back in Math 1, your lines, it would look something like this is positive, this is negative. Now we may not be dealing though with a linear equation. We may not be dealing with this line. It might be curving, but the general shape is that it's either going down or it's going up. Rate of change is just another way to talk about slope. So we've got that y2 minus y1, and this is a 2 here, divided by x2 minus x1. So when we talk about rate of change, we're talking about between the 2 points, how can we find or use that slope formula? And then end behavior. As x approaches positive infinity, what is the graph doing? And as x approaches negative infinity, what is the graph doing? That's what we're talking about with end behavior. Is the graph going up? Is it going down? So if you're following along in your packet, you're going to want to go on to the next page. And we're going to go ahead and graph this. So if you have a graphing calculator, that's what's really nice about having a graphing calculator, is that you can pull that out and we can graph that. So if you remember in your graphing calculator, you hit the y equals. You can see that. And you want to make sure none of your plots are on. And we're just going to plug this in our graphing calculator. And then we're going to hit graph. And if your graph does not look like mine, you can hit zoom and 6. That takes you to a standard window, so it should look like mine there. Okay, so our x-intercepts in this case are at 0. I'm pretty sure I should double check that actually. Give me just 1 second, guys, sorry. Oh, it's not exactly at 0. Sorry, it's a little more than 0 here. It is at 0.268 comma 0. So if you remember from Math 2, how to do this is you're going to hit second, trace, and then 0. When you hit second trace, you get a screen that looks like, I'm trying to make you see that screen that looks like this. And 0 is the second one down. And then it's going to ask something for a left bound and a right bound. So your left bound, you have to be, in this case, above the x-axis, and then you hit enter. And then go back down below, hit enter again, hit enter a third time, and you'll get this. When you do this for your other x-intercept, you'll have to start below because you're starting to the left. So I'm going to do the same thing. Second, trace, and then 0. And I'm going to bring my cursor, like I like to bring my cursor super close to the x-axis. So I start below, you can see like the little x there. I hit enter once. Then I'm going to move it above, because you always have to have one below and one above the x-axis. Hit enter for the third time, and I'm going to get 3.7 comma 0. Now, y-intercepts, super easy. I don't even need the calculator for that because I know my y-intercept has an x value of 0. And if I plugged in 0 here, this x and this x is going to go away. I'm just going to be left with 1. So I'm going to do a little estimation over here. 3.7 is about here. 0, 1 is, oops, not there. That's 0, -1 is here. And then I also need to find the minimum here. So what's nice is in the graphing calculator, you're also going to do second trace again. And there's actually a value here for minimum or maximum, and I'm going to find, in this case, it's going to be a minimum because if you remember from Math 2, this is going to be a quadratic, and you saw the graph, it's a U-shaped figure. So there is a minimum. I need to be to the left side for left bound and the right side for right bound. Hit enter again. And so I don't have a maximum, so I'm going to write does not exist. But my minimum is at 2, -3. So 2, and I'm going to plot that point there and sketch my graph. Okay, so the minimum we said was at 2, -3. My relative minimums and my relative maximums do not exist. I don't have another valley here. I only have that one valley, that lowest point. So now we have to talk about the intervals of increasing and decreasing. So we put this in what's called interval notation, and it's very similar to what looks like a point, but, and I'm going to draw this here. There's my line throughout here, and remember this was at point 2, -3. So my graph is going down from here down. So if I'm looking at the x values, my intervals are always x values. Out from -infinity all the way to the x value of 2, I am decreasing. That it's shaped down. Then I'm increasing from 2 to +infinity. So from 2 on out with the x, I'm going up. My graph is increasing. And then we have the average rate of change from 0 to 2. So remember, we're going to use y2 minus y1 over x2 minus x1 here. Now, what I do is I utilize my calculator when I can. So these are my x values, my x1, my x2. I need to plug those in to figure out my y values. I could do that by hand and actually plug that in. But I'm going to use my calculator, and if you can see that, I'm going to use second trace again. So second trace, and this time I'm going to use value. When I hit value, it asks me for an x equals. Well, if I put 0, I get 1. So I have a point 0, 1. Then I'm going to do that again. Second trace value, put in my x value of 2. And I get 2, -3. Now I have 2 points that I can plug in here. y2 minus y1, so -3 minus 1, divided by 2 minus 0. -3 minus 1 is -4, divided by 2 is -2, and that's my rate of change. Okay, let's take a look at our last problem here. And this is just a graph that we're given, so let's look at our x-intercepts, and we have just one here, and that's at -1, 0. Notice that this is going by 2, so this would be 1, 2, 3, 4, or -1, 2, 3, 4. My y-intercept is right here at 0, 1. Now this is where it can get a little confusing. I don't have an absolute maximum here. Yes, I have a mountain right here, but there are points greater than that mountain. So because, and this I'm going to assume here is going up all the way, because there are points that are higher up than this mountain, my maximum does not exist. I also have a valley here for a minimum, but again, these points all here are lower than this minimum. So my minimum does not exist. Now I do have to move the graph a bit, so I am going to point out a couple things here. This here was our 0, 1. This is a relative minimum. So it's still a valley, it's just not the lowest point. And this here, I'm going to estimate this to be, I don't know, about negative 0.75, comma, because it's like right here and there's 1. And then this is 1, 1.5, about 1.75. And this is a relative maximum. So our relative minimum, we said, was 0, 1. And our relative, oh, we don't have a relative maximum. That's okay, unless I skipped it. No, I didn't skip it. All right, so now intervals of increasing and decreasing. This is also going to be kind of difficult without the graph. So I'm going to bring the graph back down, and I'm going to try to talk about the intervals of increasing and decreasing. Anytime you have a turning point, like a minimum or relative minimum or a maximum or relative maximum, what you want to do is find the x value at that point. So the x value at this point we said was negative 0.75, and the x value at this point is 0. So if you think about this, I am increasing. So you might want to put this on your increasing page or increasing spot. I am increasing, I'm moving up. I have a positive slope coming all the way basically down here, which if I went out on the x-axis, that would be starting at negative infinity. And it increases and increases and increases till it hits negative 0.75. Then it decreases, which we'll come to. And then here at 0, it starts increasing again all the way to infinity. For decreasing, it's decreasing between negative 0.75 and 0. So again, like I said, if you can go ahead and write that in the spot. It's just a little hard right now while I'm doing the videos. And I think we have one more problem, rate of change. So let's take a look at that rate of change. And we are trying to find the rate of change from -1 to +1. So we're going from -1 to +1. Here's our -1, here's our +1. Remember, when we're dealing with rate of change, we're given those x values, but what we need to do is figure out our y values. Well, with the calculator it was easy. With this one, it's not as easy. If I look here, looks like I hit the graph here, and I can go all the way up, and I'm actually going to bring it down just a little bit so that I can see. Sorry about that. So I've got my -1 here and my +1 here, and it looks like I'm hitting it right here, which is about 5. So if I wanted to do my rate of change, at -1, I'm hitting at 1. At +1, I'm hitting at 5. So remember our formula, y2, 5 minus 1, y2 minus y1 divided by x2 minus x1. So y minus y divided by x minus x, 4/2, which is 2. Okay, mathematicians, I hope you have a great day. I know this one was a little long and I'm sorry, but thanks for sticking with me. Bye.